Chapter 2, Section 2.7, Nonlinear Inequalities. Here are the section objectives. All right, we'll start with polynomial inequalities. And when we're looking for inequalities, or when we're looking at an inequality, we're looking for, a interval or a group of numbers, a big span of numbers that would make something true. It's not necessarily going to be just a discrete list of numbers. It's going to be intervals that make it true. So in order to do this, what we want to do is look for intervals to test to see where the inequality is true and where it holds up and where it doesn't. And in order to figure out which intervals we want to test, we want to find real zeros. So we are going to be doing some factoring here. We're going to be looking for zeros, and then those will be our key numbers, and then we'll set up a test and see, where the inequality holds true and where it doesn't. So we'll start with this one. It says x squared minus x minus 6 is less than 0. We want to graph the solution set. So we need to come up with a solution set, and then we can graph it. I said zeros, which means we're going to start with taking our quadratic expression, and we'll set it equal to 0 and get zeros. I can start by factoring this, and I end up getting 2 zeros, or these are key numbers, and they are positive 3 and negative 2. So what I want to do is set up testing for both, like set up intervals where those are like the dividers. So you can set this up in a few different ways. I'm going to set it up where kind of like in a table format, where here are my test intervals. I took negative infinity to my lower one to my upper one, and then upper to infinity. So I have that negative infinity to negative 2, negative 2 to 3, 3 to 0, and then I need to pick x values in those intervals. And so I'm going to pick ones that just come easy to my head. I'm going to pick negative 3, pick 0, and I'll pick 4. So I need to pick a number between negative infinity and negative 2. I pick negative 3. Now I need to go and plug that into my polynomial value. I'll rewrite it up here. I don't have it rewritten yet. So if I plug that in, I would get negative 3 squared, which is 9. And then I'd get minus negative 3, so that'd be plus 3 minus 6. So this would end up being 6. So is 6 less than 0? I would say no. Conclusion is no, that interval is not in it. Moving on. Next one. Now I'll plug in 0. 0 squared is 0, minus 0 is 0. Negative 6 is negative 6 less than 0. Yep, it is. Negative 2 to 3 is in the interval. Next one, I'll plug in 4. 4 squared is 16, minus 4, minus 6. That would be 6. Is 6 less than 0? I would say that's a no. So the only one that worked is that middle one. And so now we know that our solution is between negative 2 and 3. Here it is typed. And I am going to show it on a number line. So it's between negative 2 and 3. And so when I go and graph that, because it doesn't have a little equal sign under that inequality, I don't want to include these numbers. So I'm going to say everything between negative 2 and 3, curved brackets. So I'm not including those. But this is what my solution, set would look like on a number line. All right. Next, if we make the inequality a little bit more complex, we might have a rational inequality. So I'll show you what that looks like. Something like this, where it's not a quadratic expression, it's a rational expression. And so with this, we first need to get 0 on one side. So I need to get rid of that 3. I'll do that by subtracting 3 from both sides. And then I need it to be a single rational expression. I can't have it be rational expression minus constant. So I need to get a common denominator and combine these. So instead of just minus 3, I'm going to multiply by x minus 5 over x minus 5, so I have a common denominator. And then now I have this common denominator, so I can subtract these fractions, these rational expressions. So I have 2x minus 7 minus 3x plus 15 all over x minus 5. And if I combine like terms, I get negative x plus 8 over x minus 5 is less than or equal to 0. Okay, so I got it down to one rational expression with 0 on the right. Now I want to look for my key numbers, I call them. In calculus, we call them critical numbers. They are numbers where interesting things might happen. And so when you're looking for key numbers or where interesting things might happen, it's where you have a 0, which would be the top equals 0, or where it's undefined. That would be where the bottom equals 0. So on the top, if I solve that little equation, I get x equals 8. On the bottom, if I solve that little equation, I get x equals 5. So 8 and 5 are my key numbers, which would be like my interesting numbers. My key numbers are x equals 5 and 8. My test intervals then would have to be negative infinity to 5, and 5 to 8, and 8 to infinity. I'll have to go and test those. I'm going to set it up like I did last time. And I'm going to pick my numbers. I'm going to pick negative infinity to 5, I'll pick 0. 5 to 8, I'll pick 6. 8 to infinity, I'll pick 9. And then I got to go plug it in. I didn't, I should have had this typed and ready, but I'll just write what we had after we simplified up here at the top. So I'm going to go and plug in 0. If I plug in 0, I end up getting 8 over negative 5, which would be negative. Is that less than or equal to 0? Yes, it is. That's a winner. All right, next I'm going to do 6. So negative 6 plus 8 would be 2 over 1. That's positive, so it did not work. That was a no. And if I do 9, I'd get negative 1 over negative 14. That is also positive, and so that's a no as well. So I ended up with only one yes, the top one. And, oh, they got another one. I wonder if I made a mistake. I better go back. I gotta go back. Let's plug in 9 again. Backing up. Negative 9 plus 8 is negative 1. 9 minus 5. I did negative 9 minus 5. 9 minus 5 is 4. So this is yes. I can go back and switch mine. So that's a yes. So we had 2 yeses. Whoops. 2 yeses. All right. Glad I found that error. Now, those are my test intervals. That was a no. These were yeses. And so if I go and graph that on my number line, negative infinity to 5 is here. And 8 to infinity is here. And in order to know, because this is a less than or equal to sign, we need to know if 5 is included, we need to know if 8 is included. So what you would do is go back and test each of those. If I try to test 5, it would be negative 5 plus 8 over 5 minus 5. That would be undefined, so that's a no. 5 would be a no, so that's why you see that curved bracket there. If you test 8, negative 8 plus 8 over 8 minus 5, is that less than or equal to 0? You get 0 over 3, which is 0, and that does equal 0, so then you see the bracket there. That one can be included. So that is our solution with the appropriate numbers highlighted and then the correct brackets showing. All right, we have an application here. We're going to look at profit equals revenue minus cost as our business application. Here this says a marketing department of a calculator manufacturer determines that the demand for a new model of a calculator is here. And X can be anywhere from 0 to 10 million. P is the price per calculator. So price here, price per calculator in dollars. X represents the number of calculators sold. So according to this model, no one would be willing to pay more than $100. And on the other extreme, the company cannot give away more than 10 million calculators or they will go out of business. So we'll start with a revenue equation. XP would be the number of calculators times the price that we sell it for. And so if you go back and take the equations from there, X we can leave as X, and P we had written as 100 minus 0.00001X. That would be my revenue. It is the number of calculators sold times the price that you charge per calculator. I could distribute this X if I wanted to make it not factored. So that is another version of that. The cost would be $10 per calculator. So we'll use 10X. X is the number of calculators sold, so it would be 10 times the calculator sold. And then we have a development cost here of 2.5 million. So this says, what prices can a company charge so that they could obtain a profit up at least 190 million? So I guess that's their goal. They want to make that much of a profit or more, and so they're wondering what could they charge in order to make that happen. All right, so profit is what you take in for your revenue minus what it costs to produce the calculators. So we'll go ahead and take what we had written before. We had written for our profit for our revenue 100x minus 0.00001x squared. That was the revenue. Minus the cost we had written before was 10x plus 2,500,000. If I distribute that and combine like terms, I will end up with, let's see, I'll write this first, my x squared term first. Then if I combine my x terms, I'd have plus 90x minus 2.5 million. So this is my profit equation. All right, and it said that we didn't, we wanted our profit to be at least 190 million. So if you take that profit equation, you set it greater than or equal to 190 million, that's what they were asking for. So if I were to graph each of these, here is my profit equation graphed in millions. So I took out the millions part, multiplied this by a million to make that more graphable. Here is my 190 line that I am focused on getting. And if you look for the solution points or the intersection points, it intersects at 3.5 and 5.5. If you add those millions back in, it would be 3.5 million to 5.5 million. You're looking at selling something in between there. What we're wondering in the beginning, it asked, what should we charge per calculator? So you'd have to go back and figure out with those number of calculators sold, what could my price be? So if you go back and plug that in, you get the price should be between $45 and $65 in order to get a profit of at least 190 million.